Okay, welcome back to Solar 24-hour channel. And today I'm going to show you how to design a tile grid solar system on PVsyst 7 version 7.0. Okay, and we are going to the detail how to choose the solar panel, how to choose the inverter for your design, and how to create the final report so you can print it to the PDF file or you can print it to the paper and use it for your representation or to talk with your customer. Okay, so at first we need to go to Google Map, and in this is the building where you want to design your system. The solar panel will on this roof. You can see here this roof. So at first we want to know the facing of this roof, and the second is the total area of this roof. So you can see here it's slightly facing to the south, but it rotating to the east. Yeah, very small angle. You can see here is the facing, and the second is the area of this roof. So how we can know that number is really easy. You use the tool we call Google Earth Pro. Yeah, Pro, but free version. You can use all the tool or the function of this software, but don't need to pay for Google anything. It's totally free. So we started with this. We came back to Google Maps. You click here and copy that. You can see here, copy this, copy, and back to Google Earth Pro. You paste here and click search. Okay, so the map is starting to zoom in, and wow, you can see that the place where we want to install our system. Okay, next we use this tool, ruler, and you click here, you can see that the number, the length of this roof. So you back to the okay, we use Google Pro. We know it's 32 meter, and next is the wind. Really easy. You click clear, click here, click here. Is 5 meter. So the total area of this roof is, use a calculator. Okay, we have 32 plus 5. 5 is this number. You see that 160 meters square. Really simple. If you can use the Google Earth Pro, because in Google Maps you just see the location, you just see the safe light and no more tools. You can know the length of this, no. The length of this, no. And on Google Earth Pro, you can see that. You can calculate, you can estimate the length and the width of the roof. Really easy, and it's totally free. Okay, so we came back to PVsyst to design a tile grid system. We click on grid connected. Okay, so we click new to create a new design, and we will change the name. For example, it's demo 1 2 3. Okay, and next you creating a new location for this project. And yeah, At that time, you came back to Google Maps. We copy the location. You can see here, copy it back to PVsyst. Click here and we paste. Click search. Okay, well, the map is starting to move. See here? That's place where we want to design the system, where we want to estimate and simulation this solar system. Okay, we click accept select point. Next, change the sign name if you want, and click import. So the import button is starting to transfer the weather data from Metronome 7.3 to PVsyst. Yeah, and actually it's your project location. Yeah, and you have the weather data for what? Really easy. For simulation, to know how many kilowatts or the productions of your solar system. Okay, so where you see this temperature, wind velocity, a lot of different. Don't care too much, just click OK, save, and then wait for a while. Okay, wait for a while. The second will appear. Okay, yeah, save it. Yes, save. That's it. Next, we have to save the project. And how? Click here, click save. Save. Okay, you see here the orientation is not defined. Next, you go to the orientation. And you can see here, we have two things. Plan tilt, azimuth, tilt angle. And yeah, tilt angle, you have to go to the side, you have to measure the tilt of this root. So in this project we have some estimation. For example, is 15 and the azimuth right there. Easy. You came back to Google Maps. You see that? It's facing to the south, but slightly rotate to the east. So we back to PVsyst. You see here? We moved your mouse to this, your cursor. Click and you rotate. You see here? Click and rotate. Yeah, you see that? It's rotate. And for example, you see here is quite good. The same with this. So after that we click OK. And next we going to define the system. Yeah, we define the system to know what kind of solar power. At first, interplane power or area. Okay, so we know the area, right? In the calculation, you have this number, so you came back and enter this number. Next, we going to choose the solar panels. For example, in this we use the Zinco, for example, and I choose this type of solar panel. You can use any type. But here we use this. Okay. And the next we going to select the inverter. For example, we use sun grow. Yeah, sun grow. Okay, right there. We choose sun grow, right? Sun grow. It's about 32.8 kilowatt peak for this area, right? So we choose this type of inverter is about 30 kilowatt, and I choose this. It's fine, right? So we have the total number of module is about 79. So why 79 of 79 module of Zinco solar with the power of 410 watt peak. Okay, so we will use 80 is the nearest number, right? And with 80 module we will use this. So what does it mean? It means we have 20 module in series and divide into 4 string. Yeah, 80 module divide to 4 string, and each string we have 20 module. You can see that 20 module. So right there we see PVsyst one we know that between 8 and 18 is the great number. Yeah, it's a great number. If we use more than that, it will not good for our design. So I will slightly change. And when I change the number, yes, the number of module is decreased. You see here 72 number, and so we just need 72 solar panel or modules for this design, because it will match with the inverter, right? If it is 160 meters square, we can use maximum at 79 module, right? Yeah, but the solar panel need the inverter to transfer the DC to the AC, and when you use the inverter, it means we have to match the voltage, we have to match the current with the inverters, and we have to have the configuration match with the inverters. So we need 4 string, and each string we have 18 modules. That is the match with the inverter. The reason why we just use 72 module instead of 79. Yeah, see there? That is the reason. Okay, so we configure it successfully, and we click OK. And just we came back to the system. You see here we have the P norm ratio. What does it mean? P norm ratio is the power of your module total, and divide for the inverter. So you can see here PVsyst talk to you that inverter power is slightly oversized. So what does it mean? We have to add more. We have to add more module, right? But it doesn't matter, right? If you use this configuration, that's okay. If you want to maximum the inverter performance, you can use this method. We will change the power or change type of solar panel we use. For example, I will use this. Okay, for example, and right there I will change the way I use. For example, file string. Okay, we change to some lower. For example, here, and click here. Okay, for example, use 6 with 12 solar panel, increasing more, 6, 15, 17, and you will see here 17, right? 17, but it's too much with our module, right? So what does it mean? Is panel ratio you want to increase is near 1.2. Yeah, 1.2. Near that value is really good, because it's the best performance for your system. Okay. Also, okay, that is the method. We came back to use this solar panel here, slightly oversize. That's okay, no problem. Click OK, and then next we go into the detail losses, and you would choose the way you install the solar panel. For example, our building right there, yeah, we use aluminum. We use the roof. Install it. By the way, is here, semi-integrated, because we use the rail, aluminum rail, to install the solar panel. Yeah, so we choose that. If you free mount module with air circulation, it means you use the steel frame. Yeah, so the solar panel is higher than your roof. It's about 1 meter. It's about half meter. Anyway, it means in that situation you choose the free mounted module with air circulation. But in our building, we use the aluminum rail, so we choose that. Okay, and the next is army losses. Army losses we have two, is DC circuit and AC losses. DC circuit and AC circuit. DC circuit, you can click here and enter your value, your estimated value. And the second thing, you can use the detail computation. Right there, we click on here, we estimate the length of this wiring. Enter, for example, 10 meter. In man's box to inverter, for example, is 20 meter, and we use this cable. Okay, and next click OK. We go to AC losses. AC losses here. You estimate the length of the AC wire. For example, we have 10 meter. Okay, go into soiling losses. Yield loss factor. You can enter the values you want, or you can use default. Oh, next, we go to the aging. You can use it in simulation. Click here, and this on availability. Yeah, you can enter the fractions or the duration or the number of periods for this, or we can set random, right? Depend on your design. It's not too much important for our design, so we will go to click OK. The most important is thermal parameter, ohmic losses, soil loss, aging. Okay, we click OK, and next click here to run simulation. So in this design, we're not going to calculate the shading. Shading is not here. Shading is in the next video. I will show you how to calculate the shading and how to design and estimate the shading effect on your system. Okay, so when we run the simulation, when it finishes, you click on the report. Okay, we have 4 pages, and the first pages of your report. You can see here the information of your location, simulation parameter, PV array characteristic, module inverters, all the thing you need. Yeah, P-norm ratio. And the next, in the second page, we have here some table, some graph with the performance ratio. And here's the really important. When we calculate, when we use PVsyst, just one here. You know the production of our system for each month and total in year. See here? Also the ratio, performance ratio. Okay. And the next is some diagram. Yeah, you can see here 2 diagram. It's about the energy that the system, and the final page you can see here is the loss diagram. It's really important because you have to use this to know the losses of our system. For example, we have here PV loss due to temperature 7.443 is the highest value, right? So you can see here, and you know what is the losses of our design. Why solar power never working on the best performance? Yeah, easy, right? Because it's in the STC standard, or we call standard test condition. It's not the real conditions in our environment, in our real life. And we can see that in real life, what's the effect to our system. That is in loss diagram. You can know all the things. Also, you know the number, the value of the loss. So, okay, and you can save the document as PDF. You can review it at any time, or you can bring it to paper. You can bring it. Okay. So we save this, or we can save it to desktop, our desktop. Okay. I will type for name. Okay. And you can open. Also, we can export some graph right there. yeah, you can go here and you select the values you want to. So that's it. That is the flow. How to design a solar tiger system on PVsyst version 7. And yeah, if you have some questions, if you have some comment about this video, or you want to ask for more detail how to do or how to design your system, you can use the comment below this video. Okay, I will share with you all the things I know to help you. And thank you a lot for hearing my for seeing my videos, and hope that the videos I made help you to learn about PVsyst and to use it in your design. You can be a designer, you can be a solar lover. You PVsyst to design. And I hope that this video will help you. Thank you so much, and see you in the next videos on our channel, Solar 24 Hours. Thank you, and see you later.